I apologize. If you watched that low energy last video, you might have gotten the impression that math was boring to me, but I am all caffeinated up, and I'm going to do this question on the next page, just because I was running out of some space. All right, so let's see. So we would want to take the derivative of both sides. So first thing that I notice here is that I have a function inside of another function, right? So right off the bat, this is going to be a chain rule question, right? So I know that the derivative of the square root of anything is equal to the derivative of the inside over 2 square root of that inner function. All right, so that means that I need to, so this is my u, so that's going to go right into my denominator, but I need to take a derivative of this thing. So let me do that, right? I got the sinh of x over e to the 4x plus 3. When I take the derivative of this, well, I got to use a quotient rule, right? I got a function of x over a function of x. So our quotient rule is going to be our bottom function, e to the 4x plus 3 times the derivative of the top function, derivative of sinh, minus our top function, so sinh of x, times the derivative of our bottom function, e to the 4x plus 3, over the bottom function squared. So I got an e to the 4x plus 3, whoops, plus 3 on the bottom, whole thing squared. All right, so I would look at this and say, you know what? These are not bad derivatives to take. I could just take a straightforward derivative of sinh. This is just since that plus 3 is the bottom, not the top, but like I wrote, that is an awful 4. So I could just take the derivative of this 4x plus 3 term by term as well. All right, so I'm going to get the derivative of sinh, which is the cosh. So I'm going to get e to the 4x plus 3 times the cosh of x minus the sinh of x. So e to the 4x, technically that's a chain rule, right? So we got a derivative of e to the u is u prime e to the u. So I want to take the derivative of my numerator, which is the 4. And then I'm going to get an e to the 4x. And the derivative of 3 is just 0. It's gone. Be gone. You're banished. And then we have this denominator squared. All right, so here we can do a little bit of simplifying, right? Because we have no, we actually can't do a little bit of simplifying. We're kind of good there. So that's our u prime. All right, so then now if we kind of put this all together, derivative of a y with respect to x, I'm going to get a u prime. So I'm going to get this entire function in my numerator. I'm going to divide this entire function by 2 times the square root of my function u, which is right here. So this is about as good as we can get it. There's a 100% chance we could like simplify and do some stuff with things here, but there's no reason. There's nothing other than flexing our math might there, which you can do on your own time.